Hi, I'm Yadi. This is my multi-tenant serverless log processing system. It's an event-driven pipeline on AWS that handles over 1,000 requests per minute and processes logs asynchronously and provides strict tenant isolation. The system is 100% serverless and has 96% task coverage. Let me show you the live deployment. Here is the AWS Lambda console, and I have two Lambda functions deployed. The Ingestion Lambda was triggered by API, and it handles API requests, validates input, and queues to SQS. And the Worker Lambda was triggered by SQS, processes messages asynchronously and stores result in DynamoDB. This is SQS queue console, and this is main queue. This main queue with 15-minute visibility timeout, and that latter queue for failed message. And another queue is that latter queue. This provides automatic retry for crash recovery. Here's DynamoDB table, and currently it's empty. But let me send requests and show you the complete asynchronously processing flow from API to database. This is Postman, and I'm gonna send two requests, one in JSON format and one in text format. First, for JSON format, I'm gonna create one request for tenant A and with sensitive information. After sending, we receive the tool to accept instantly, and we move to the text. We notice that the content type is text and the tenant ID is tenant C, which is come from X tenant ID header, and we're also gonna put some sensitive information into body. Yeah, we can see both requests return immediately, so it shows the API is non-blocking. Now let's watch the CloudWatch to see the asynchronous process. This is CloudWatch Live Deal console. There, we can say the Ingestion Lambda received the requests from tenant A and queued them to SQS. And a few moments later, the Worker Lambda is picking up message from the queue and then process it and finally successfully processed. This hot flow demonstrates the asynchronous flow, which is API accepts immediately and workers process in the background, multiple messages processed in parallel. Now, let's check the database. Perfect, both process logs have appeared. We can see two records, one from JSON request of tenant A and one from the plain text request from tenant C. Let me show you the data structure and the tenant isolation next. Here is a database structure. Each record contains partition key. This determines the physical partition, and sort key. This is unique identifier within the partition. And there's another data fields like inject time, log ID, modify data, original text, process time, and process time second, and source, tenant ID, and text length. This structure provides both tenant isolation and data security. Let me highlight the PII redaction. In the original text, you can see a lot of sensitive information like email, IP address, and phone number. But in modified data, all of that sensitive information have been redacted. These systems automatically detect and scrub sensitive information while preserving the original for audit purpose. And when we look into another text format request, we can see all the data were stored correctly. We have partition key, we have sort key, log ID, and most important, in our original text, we have a lot of sensitive information, but in modified data, all of that information were redacted. Now, let's look into the most critical part, tenant isolation. Look at partition keys, tenant hash tenant A, tenant hash tenant C. These different partition keys mean the data is stored in different physical DynamoDB partitions. That means when you query for the tenant A, DynamoDB only can access the tenant A partition. You cannot query across tenants. If you want to change A to C, same result, you only can access the tenant C. This is not a flat table where all logs are mixed together. This is physical separation with partition-based isolation. You cannot query cross tenants. To summarize, multi-format ingestion, asynchronous processing, automatic PI redaction, and physical tenant isolation with partition keys. My system is serverless and production ready. Thank you for watching.